Welcome to my experimental study and thanks for participating today. My name is Christina Adam and I'll be showing you a brief tutorial video about two data modeling approaches that will be subject in today's experiment. First of all, what is a database? A database is an organized collection of data ideal for storing as well as retrieving information. So basically a bunch of tables that hold your information, but they're linked so you don't get a lot of duplicate data. This makes it easier to find your information later because you can make a search instead of seeing the data all at once. The first step in creating a database is to create a data model. A data model provides appropriate structures of data that address and support the business requirements. So you might want to ask yourself what are the things that need to go in a database and what information you want to keep about those things. There are two kinds of data models that we want to look at today. The diagrammatic entity relationship diagram, short ERD, and the text-based, fact-based information modeling language, short FIML. Let's have a look at the ERD first. The main concepts of an ERD are entities, attributes, and relationships. Entities are displayed as a rectangle that contain attributes and can participate in relationships with other entities. So entities may be representing a person, place, thing, or event that you want to track in a database. For instance, an employee. The entity employee is a representation of all employees in the real world. Now we want to define the employee a bit more, and therefore we need attributes, which are basically pieces of information about the employee that we want to know. So here we might want to know the employee's first name, last name, date of birth, start date, and position within the firm. A particular instance of the entity employee could be Michael Adams with his date of birth, start date, and business analyst as his position within the firm. Next, we want to make sure that we can uniquely identify each of the employees. However, none of the attributes we've defined so far can ensure a unique identity, as there could be two employees with the same names, for example. And hence we need another attribute that uniquely identifies the entity, such as an ID or a code that is only used once. In an ERD, a unique identifier is an attribute that is underlined, in our case, an employee ID. Now, to connect information with each other and be able to navigate around in a database, entities participate in relationships. A simple example is the one we've got here with employee and department, where we can say an employee works in department and department has employees. So clearly there's some sort of relationship between those two. But we also need to specify the type of relationship by saying how many instances are allowed or necessary between those entities. We've got four different options, and here we talk about cardinalities. The first one is one mandatory, saying must be one, which we draw by two single lines, the first one for mandatory, saying must, and the second one for one. The next one is many mandatory, saying must be one or many, which we draw again by a straight line for mandatory or must, and a little crowfoot for many. The next one is one optional, saying it may be one, and may implies it can be zero. So we draw that by a little circle, which is may or zero, and a straight line for one. And many optional, saying may be one or many, and again, may means it can also be zero, which we draw by, again, a little circle for zero, and a little crowfoot for many. If we now go back to our relationship example, the relationship between employee and department could look like this. So employee must work in one department, and department must have one or many employees. So it is a mandatory many to mandatory one relationship. There's also a particular way of how we verbalize the relationship, and that we do in a clockwise manner, and we also identify descriptive labels that match how we would read from employee to department and from department to employee. So in our case, that would look like the following. Employee must work in one department, and department must have one or many employees. We could have also identified the relationship on the employee side as optional many, and then we would say department may have one or many employees, implying could also be zero, but that would imply that a department can exist with no employees assigned to it. And just because I thought it's not very realistic to have a department without at least a head of department assigned to it, we just leave it as a mandatory many relationship. To now complete the relationship and allow navigation through the entity structure, we also take the unique identifier of the one side of the relationship, which in our case is department ID, and copy it into the entity with the many side of the relationship, which is employee. And that step creates the actual linkage between two entities. And now we are able to move between those entities via this particular attribute. And to make sure that we know that department ID is the unique identifier of department and not of employee, instead of underlining it, we write it in italics. So now every time we need information from different entities, we can move around entities and move in between entities where we've got or need information from via the unique identifiers, as they create the linkage from entity to entity. We can also come across cases where we want to identify an entity by a compound identifier, which means that the identifier consists of more than just one attribute. For example, in our case here, we have employee who's assigned to an assignment, and the assignment describes a project. Instead of identifying a new assignment ID, we can just copy the unique identifiers of both employee and project. And again, remember that these are on the one side of the relationship, and copy them into assignment, which, just as we've done before, creates the actual linkage. And that's why we write both employee ID and project ID in italics. But because those two combined together can also ensure the unique identity of an assignment, we can just make it a compound unique identifier of assignment, and that's why we also underline it. The last concept is about subtypes. Subtypes apply when we have an entity that can appear in different forms and hence require some different information. For instance, an employee can be an employee on an hourly rate or on a contract. While both will have the same attributes that are defined in employee, which are employee ID, first and last name, date of birth, start date and position, they each will have some additional information. For an employee on an hourly basis, that might be the hours agreed on and the hourly rate. And for a contract-based employee, that could be contract details and salary. In an ERD, subtypes are displayed in the following way. As we said, each subtype inherits all the attributes defined in its so-called supertype, here employee. That means that, for example, hourly employee doesn't only possess the attributes hours and hourly rate, but also the 6 other attributes defined in the entity employee, including its unique identifier, employee ID. Subtypes also inherit relationships from its supertype. So let's say employee has a relationship with department. Then this relationship applies to both hourly employee and contract employee as well. There can also be situations where only one particular subtype of an entity participates in a relationship with another entity. So in this example, contract employee must work for one contract agency, and this relationship only applies to contract employee, and that's why it's directly connected to this subtype. To complete the linkage in the relationship, again, we have to take the unique identifier of the one side of the relationship and copy it into the entity of the many side of the relationship. So that's why agency ID, written in italics, goes into contract employee. Here we can see a complete model of the concepts that we've talked about. Department which must have one or many employees, where employees can be an hourly employee or a contract employee, and a contract employee must work for one contract agency, and employees that may be assigned to one or many assignments, and an assignment which must describe one project. Please take a few moments to go through the model again. Okay, so something I want to add here, which is quite common to come with an ERD, is a data dictionary. A data dictionary gives plain business definitions about the entities and attributes that are contained in the model. For example, the first one here, assignment. Assignment is a task allocated to someone within a project. For attributes, the data dictionary further contains value types, and value types tell you the value that each of the attributes can be stored in. So for example, the number, text, a date, or a dollar value, which are the most common ones. So we've now covered the basic concepts of an entity relationship diagram. We're now going to explore another data modeling technique, which is essentially different from ERD. Instead of using a diagram, the fact-based information modeling language, short FIML, uses only natural language text to describe the model. And the main difference is that FIML doesn't use the concept of attributes, but quite different structures and concepts instead, which we'll look at now. So the main concepts of FIML include objects, which are things of interest that can be values or entities, facts, which are the relationships between objects, and roles, which are the parts an object plays within a fact. Starting with objects. An object is an individual thing of interest. An object can occur in two different ways: as a value, which is something that we can write down or store, such as the name Michael Adams or the number 12345, or as an entity, which describes a thing that cannot be written down, such as a person or the employee Adams. Going from the real world into FIML language, we now use object types to provide a definition of the characteristics of a set of similar objects that each instance can make use of. So for value, we said we can write it down, and FIML now defines how it is written down. So for example, we say each name is written as a string, each ID is written as an integer. And string and integer are particular data types that we're not going to put too much emphasis on for this experiment. For entities, we said they are something that cannot be written down, so we need to find a way to identify them, to write them down. And that is done by saying each employee is identified by employee ID. So we identify employee by its employee ID, and we can make a shortcut by saying each employee is identified by its ID, and FIML automatically creates employee ID, which is uniquely assigned to employee. The next concept of FIML are roles, which enable the same object type to occur multiple times in a fact type, but in different roles. So it's basically a part played by an object type. There are three roles that we want to distinguish: the direct role, which is just the object type itself, such as employee; the qualified role, which is a part of or a further distinction of a role by specifying adjectives to the object, such as first name; and the explicit role, which is where we provide a distinctly different name for a role, such as name as CEO. And remember, because we can't write down a person, such as a CEO, we address it by its name. So that's why name as CEO. Next, we want to look at the concept of facts, which are relationships between roles that objects play. We distinguish between the number of roles that objects play that are included in the fact. One role included, employee Adams smokes. Two roles included, employee Adams works in department IT. And more than two roles included, employee Adams works in department IT on project test. Each of these readings is a meaningful sentence relating the roles of affect type in close to natural language. A reading is often constructed from a verb between the first two roles and a preposition between the following roles, such as in the third example here. Facts between two or more objects can have multiple readings representing the different ways the same information can be expressed in natural language. So instead of saying employee Adams works in department IT on project test, we could also say project test is executed in department IT by employee Adams, and it would display the same information. Fimmel now defines fact types to provide definitions of relation patterns between one or more roles. And again, we have the readings between different numbers of roles included. And as you can see, the Fimmel text is just as our real-world examples before, just without the actual instances. So employee smokes, employee works in department, and employee works in department on project. There's also a bit of a special case that we call named fact types. That occurs when we have a relationship, so a fact type, that we want to store more information on. So an example is employees assigned to project. Because we can only store information to employee and project, but as I said, we might have cases where we want to store information about the fact type. We make the fact type an object type, so we can actually store further information to it, such as date and hours. The way that is displayed in Fimmel is by is where. So we say assignment is where employee is assigned to project. If you think back to the ERD, we said there's always two-way verbalizations. So we have the same thing in Fimmel, which are called two-way readings, which means we don't only go from employee to project, but we also look at the relationship vice versa. So we add project engages employee. Similar to ERD, we can identify quantifiers, which define the number of objects participating in a fact type. In fact types, the quantifier is always written before the last role of the reading, which we'll see in a second. So the quantifiers are 1, which means exactly 1, and then example is employee works for one department. That's the equivalent of 1 mandatory in ERD. At least 1, which means 1 or more, and an example is department has at least 1 employee, which means many mandatory in ERD. At most 1, so say 0 or 1, an employee has at most 1 position. The equivalent in ERD would be 1 optional. And many, so anything from 0 to many. And an example is employee is assigned to project. As you can see here, many as a word is not actually written down in the reading. And that's because it is implied. So whenever you don't see any of the 3 quantifiers, it is many, and the equivalent of ERD is many optional. Now we want to look at a little example and compare Fimmel and ERD. When we look at the ERD, we have an employee who must work for one department and a department who must have 1 or many employees. When we create the Fimmel model, we first identify the entities, both by its ID, and Fimmel again by saying its ID creates the actual employee ID and department ID. Then identify the fact types, where employee works for one department and department has at least 1 employee. So we have the quantifiers in here, and this relationship is equivalent to the relationship in ERD. And then define the roles that employee and department play in the fact types. And in ERD, those are not roles, but written as attributes. Another concept of Fimmel is subtyping, where all subtypes possess the same characteristics as its supertype. And in Fimmel, this is written by as a kind of. For example, contract employee is a kind of employee, and hourly employee is a kind of employee. When we look at the ERD again, and remember that all the subtypes were inheriting all the attributes and relationship of its supertype, it is a similar concept for Fimmel, where the object types have the same characteristics of its supertype. Having covered the main concepts of FIML, this slide now shows the complete model of our example used in this tutorial. First, we identify the value types and then the entity types, where each employee, department, and project is identified by its ID. Then the two subtypes, contract employee and hourly employee. Then define the fact type, the relationship between employee and department in a two-way reading. Then on the right side, we continue with the named fact type assignment, which is where employee is assigned to project and project engages employee, and identify the roles that each employee, department, contract employee, hourly employee, and assignment plays within the fact types. Please take a few moments to familiarize yourself with the model. So we've now covered the main concepts of both modeling techniques. And before going into the experiment, I want to give you a brief run through so you know what you're expected to do. You're presented with a set of demographic questions, survey questions, with a total of 44 questions to 4 models, and some self-estimation questions about the models at the end of the experiment. The models will be 2 ERD models and 2 FIML models, both in a simplified and more complex version. Please make sure that you read the questions and instructions carefully. When you're provided a link to the models, make sure that you have 2 windows open side by side, one with the model and one with the survey, so that makes it easier to simultaneously look for the answer within the model. Please also take your time to answer each question properly. However, try not to pause or go away from the screen, as the time will be tracked that you take to answer each model. In case you do get interrupted, note down at which question you stopped, for example question 5 model 3, together with the length of your interruption. At the end of the survey, you will be provided a comment field where you can note down this information. Okay, now I just want to show you how you access the models, and therefore I'll go into the survey, and when you get to that point where you're presented with the first data model, which is a simplified ERD, you see a link here where you please right click and say open link in new window. So that opens the window for the model, and that's the simplified version here, and below you'll see the data dictionary where you can look up entity and attribute definitions. The complex ERD will be exactly the same, but obviously the model will be bigger and hence the data dictionary will be longer. And as I said before, you just readjust the size of the survey window as well, so you can click through the questions here and simultaneously look for the answer in the ERD. Okay, so I'll close the model and just show you a FIML example as well. So for example, when you get to the second data model, which is a simplified FIML version, you again right click on the link and say open link in new window. And different here is that FIML actually opens in a browser because it is embedded into this tool. And we have an editor, glossary, and output up here. You will only be looking at editor and glossary. The editor is really just a plain model all on one page, so there would be quite a bit scrolling involved. That's why you'll probably find it helpful to work with the glossary, as you have all the concepts contained in the model on the left hand side, and you can just click on any concept that you want to know something about, and then you get a definition. So instead of having a data dictionary, FIML actually has the definition embedded into the concepts here, and you see the whole usage of sale in this case, how it appears throughout the whole model, so you don't have to do any scrolling and searching. And you also see that by mousing over object types that you can actually click on those. So from sale you can here click on customer and you get redirected to customer, and you see again the definition, how it's identified, and its whole usage throughout the model. Okay, and then as I said before, again just readjust the size and you click on next, and then you we'll go through the questions for this particular model until you get to the screen where you open up the next model. Okay, so we've now come to the end of this tutorial video. Thank you very much for listening and especially for participating in my experiment.